continuation of reduction formula for integration of cos raised to nx with respect to x. In the previous classes we have completed tan, cot and sin. Okay, and also evaluate the integration of cos raised to 6x with respect to x where n is a positive integer. Consider in is equals to integration of cos raised to nx with respect to x. As similar to that sign, split up as n minus 1 and 1. Okay, plus 1 minus 1 get cancelled, so it is cos raised to nx only. It is the product of two functions u and v. Okay, so apply integration by parts. So this formula, so that is integration of u into v with respect to x equals to first function u into integration of the second function minus double integration of the second function into differentiation of the first function with respect to x. Okay, so first function, so that is u as it is cos raised to n minus 1x, integration of the second function cos x, integration is sin x minus sin, double integration of the second function, it is already one time integrated, therefore integration of sin x into differentiation of the first term, it is of the form x raised to n, x raised to n differentiation is n x raised to n minus 1, therefore it is n minus 1 into cos raised to n minus 1 minus 1, so it becomes a cos raised to n minus 2x, but in place of x it is cos x is there, so its differentiation is minus sin x with respect to x. Okay, so in the next step, so first term you have to write as it is minus of minus, so it becomes plus, integration is with respect to x means n minus 1 is the constant term, take that outside, into integration of cos raised to n minus 2x into sin x, so it is a sin square x with respect to x. So trigonometric identity, sin square x plus cos square x equals to 1, sin square x equals to 1 minus cos square x. Okay, so this first term as it is plus n minus 1, just you have to replace this sin square x by trigonometric identity by 1 minus cos square x with respect to x. So in the next step, split up this bracket, so that is n minus 1 into cos raised to n minus 2 into 1 with respect to x, so this term, next minus plus, so it is minus n minus 1 into integration of cos raised to n minus 2x into cos square x with respect to x. Okay, so in the next step, first term as it is plus n minus 1 into here integration, so integration of cos raised to nx with respect to x we are considering as in, and here it is cos raised to n minus 2x means, so it becomes in minus 2 minus of n minus 1 into plus 2n minus 2 get cancelled, so it is integration of cos raised to nx with respect to x. Okay, so this we have to consider as in. So next step, transposing the above equation, so this minus of n minus 1 into in, so this term, so we have to take on LHS part, already in is there, therefore in into bracket this minus n, it becomes plus n, and minus of already here it is 1, in into bracket 1, that is in, minus of n it becomes plus n, and minus minus plus 1, so it becomes minus 1 is equals to, so this term as it is plus 1 minus 1 get cancelled, therefore in is equals to, so this n comes to denominator of that RHS part, therefore in equals to cos raised to n minus 1x into sin x divided by n plus n minus 1 divided by n into in minus 2 is the required reduction formula for integration of cos raised to nx with respect to x. Okay, so if the reduction formula itself is asked, so this is the answer for that. Okay, suppose the in related to along with this question, if they have given and hence evaluate integration of cos raised to 6x with respect to x, then only you have to continue this example. Okay, call this as equation number 1. In order to find cos raised to 6x means n equals to 6 we have to find out, that is in place of n we have to put 6, so it becomes I6 equals to 6 minus 1, that is 5, n means, so that is 6, n minus 1 divided by n, that is 5 by 6, in minus 2, 6 minus 2, so that is 4. Okay, so I4, so I4 means, so again you have to substitute in equation 1, 4 minus 2, so that is 2. So again in order to calculate this I2 value, so substitute in equation 1 2 minus 2, so it becomes I0. Okay, so I0 means, so that given integration, so cos raised to 0x, so that is in place of n we have to put 0, anything raised to 0, so that is 1 with respect to x, so it becomes x divided by 2. Okay, so this I2 value we have to substitute in equation number 3. We get I4 value. I4 value we have to substitute in equation 2, so we will get the required I6 value. Okay, so we get this is I6 value, so multiply this 5 by 6 throughout that equation, so we'll get the required equation. So that we clearly discussed in online class also. Okay.